Yeah, got it. Got
Yay!
it.
Success.
You got it.
Oh my God, that was painful. Okay,
Finally.
I'm so
Patience.
sorry.
Patience and
Patience is the
teamwork.
key.
Yeah. Okay, let's go. Mikhail, take your
All right,
time.
I'm gonna go ahead.
And
So like Sandy
in.
told, like Sandy was telling, right, about the business analyst. So, but right now I'm planning for Salesforce admin. Like maybe in future, I would like to give the certification. So that sounds good, or like, what is it?
yeah,
Work?
come to next meeting to learn more about this. Let's now Mikhail to tell us
Yeah,
what he's about.
sorry. I can. My name is Mikhail. Mikhail Nitko.
Hi, Mikhail.
I'm a 9-time certified Salesforce certified CRM analytics specialist and application architect. I'm relatively new to Huron, coming from higher ed, and I was formerly the senior developer at Boston University and CRM program manager at UMass Boston. I'm also a running and coffee addict, was not missed the Buffalo Turkey Trot in 8 years, and who proudly brews his Tim Hortons in his office while his Boston coworkers make fun of him for his Canadian coffee. I felt that that would endear me with this group. I have not let go of that tradition.
Of course.
And yeah, here it's Dunkin' rules, and it's a problem. So I have to order my own off Amazon and brew my own. Anyways, so what I'm here to present on is CRM Analytics, which is a tool from Salesforce that is designed to do a couple things that Tableau CRM is not, now that Salesforce owns both CRM Analytics and Tableau CRM. And the use cases I'll be presenting is for CRM Analytics in higher ed. So I'll be speaking from that frame of reference. And the things which CRM Analytics specifically is designed to do that might be useful to you is that it can combine data from outside of Salesforce with data inside of Salesforce and produce for you analytics that you can view inside of Salesforce without pumping the data from outside into your own Salesforce org and then inflating your storage costs. The other and possibly more important part of what Einstein what CRM Analytics does is that it includes Einstein predictive modeling. Einstein discovery is what they call it, which is essentially Salesforce's attempt to democratize data science that will lead you through steps that will allow you to not just combine data from any location that you can imagine with Salesforce data, but also to create a predictive model that will let you see all the correlations that you might not have seen before with all this data combined. And then if you wish, it will allow you to deploy this model inside of Salesforce and create predictions on, for example, how to turn prospects into applicants or how to convert opportunities. What are the next best steps that you can take on an opportunity if you're in sales, or how to maximize a certain number. Let's say you're trying to sell something and it'll give you a list of suggestions based on all the data from all the previous, let's say, opportunities that you have ever had. What has led people who were involved in that to pay more or buy a different service or whatever it is that you're trying to optimize. So it's democratized data science is what it is. And I'll be talking about the use cases for it in higher ed. So what you see on your screen is all the different names of which it has gone. And I shouldn't say all because it's actually older than even this. So whenever you hear CRM Analytics, Tableau CRM, Einstein Analytics, or Web Analytics, it's all the same tool. And we'll be abbreviating it today as just CRMA. And I'm going to go to the next slide. So for our purposes, the unique features that I'll be showing will be the data enrichment and dashboards. So data enrichment is what CRM Analytics calls when you take data from outside and combine it with data inside of Salesforce. And predictive modeling with Einstein is the generic name for the data science component of CRM analytics. So the questions that we'll be trying to answer for admissions is, I don't, actually, let me first ask, is there anybody here from higher ed?
Nash is from higher ed, but most of the group is not. But they will be able to correlate. I believe they're smart people.
Okay, so I will try and relate this to more than just admissions for you, but I'm gonna make it on the fly. Okay, so admissions questions for CRMA. Admissions in a university is the department that tries to find prospects through doing things like purchasing lists of prospects or through marketing through Facebook, Twitter, LinkedIn, billboards, SMS, anything that you can imagine to try and recruit as many people as possible. In addition to that, they more traditionally hold events such as going to high schools, going to different cities across the world to put on presentations about their universities, and eventually, and nowadays also virtual because of what happened with COVID. So virtual has become very big in this recruitment space. And all of these events, either on campus, in a high school, in a city, or virtual, have applicants that result out of those events. And it is tracking the yield of each event that gets us to what is useful. It gets us to be able to plan what events to continue to hold. So the list of questions that we have here, the first question is, what recruitment events are worth continuing year after year? And the other three questions are for the data science predictive modeling that we were talking about earlier. And I'm going to focus on the first question for now, because it is the most prevalent to what I'm going to explain. So, as I said before, CRMA combines data from inside and outside of Salesforce. In our case, what we will be combining is prospects, events data, so their event attendance, and their historical application data. So this is the data that can come in from the outside and which you may have so much of that there's no way you're storing it in Salesforce. The cost implications for storage would be too high. For non-higher ed people, this would be like if you had use cases for, let's say you do a whole bunch of activities that lead to sales, but your outcome for sales, like the sale that you actually made, is held in another system. So the total amount that you have earned from going, or how many clients you received after going to some kind of convention, or how many sales you made after putting on a certain presentation. All these different things can be stored in multiple systems, and you would bring them together in exactly the way that I'm going to show you. In higher ed, we'll bring event data together with historical application data. So here I'm going to go ahead and do the live demo. Take that risk and tempt fate. All right, here we go. So the way that you get CRM Analytics in Salesforce is you purchase a CRM Analytics license. And once you purchase that license, you will have the analytics app called Analytics Studio be available to you in Salesforce. And we're just going to start from the very first screen that you get when you get CRM Analytics. You log into Salesforce. Here's your app. Here's Analytics Studio. So our goal at this point is to create the dashboard that I talked about in the beginning that will show you the yield of our events over time, so that we can choose to, let's say, cancel certain events in the future because certain other events that yield more applicants and we have only a certain amount of people who can actually do these events, who can put on these presentations and go to different schools. And we have regional differences. So in certain countries, let's say, it might be easier to recruit applicants than in others. And all these things that event planners live or die by, essentially. So the way that we would start doing this, once we have the analytics app installed, which you don't install, you just pay for the license. You first, as I mentioned, log into analytics, and then you go to, this will be slightly technical because I wanted to show people just a overview of what you technically need to do to enable this, because I don't know what level you are starting from to reach this point, because often in higher ed, it is very few people who wear multiple hats to get to this point. So I wanted to just broadly describe the technical elements of this. You go into Analytics Studio, you go into Data Manager, and here's where you will have a tab called Connections. So you will connect to your data here, whether it's in Salesforce or it's outside of Salesforce. And I know that since this is not all higher ed and not all purely Salesforce people, I just want to demonstrate something really quick. Salesforce CRM Analytics has connections to a whole bunch of different places. So Heroku, Oracle, Amazon, Snowflake, and they just keep increasing how many they do it. HubSpot. So here you will create your connections. For us, our connections are to our own Salesforce objects. So in our case, it'll be events and contacts, which are our prospects, and event attendance, which is the instance of a prospect attending an event, also known as a junction object for those who are more in the developer space and admin space. And finally, we have applications. So those are the 4 objects we'll be joining. The way that we join them is in what Salesforce calls a recipe. In a recipe, it works very much like an ETL tool. If you know, like extract, transform, and load tools like Boomi, or if you know essential database concepts, or if you simply just watch enough Salesforce Trailhead and go through enough trailheads to learn these things, or get the formal training, this will be fairly understandable to you. So I'm going to go ahead and go into the event yield recipe. And as you can see, it's very visual, and I've pulled in my sources, the event attendance, events, contacts, and applications into this. I've joined them just like you do in a database or in an extract, transform, and load tool. And then I created transformations. Transformations are what allow me to bucket different things, like bucket term and year in our case, for our students, so that we can create filters later on, and to create formulas and conversions, like I'm converting this event year to text. And complicated formulas, like right here, I'm using a formula that says when there is no ID for the application of a particular event attendee, that means that they didn't end up applying. Therefore, this field that gets created here called is applicant will show up as false. This is so that we're able to contrast in our dashboard what percentage of attendees out of total attendees actually ended up applying and doing other things that I will demonstrate. And eventually and this has so many more functions, we just don't have time to go over all of them, but it is a lot of fun to explore if you like analytics tools like I do. I'm the one who became like hooked on this suite after my own personal training. So if you guys want to geek out in analytics, hit me up on LinkedIn. And then the final node that I just mentioned is the output node. And we have events yield as the name for the output. which is a data set name. And from this data set, we can include it in either Einstein Discovery Predictions or in the dashboards in a way that I will demonstrate.
Can you,
So-
excuse me for a sec, can you show us the joins so we can also see?
Yes. So the joins offer all the traditional database joins that you can imagine, in addition to your lookup style join, which is more, I think it's probably available in other systems as well. It's not just Salesforce relevant. But the fun part about this one is that if multiple matches are found on the second table that you're joining to, it will return only the first match.
Oh, okay.
So it's a way of troubleshooting different things that is specific to this tool that I have not seen in all the tools that I've used, but might be available in some others in different forms, and I just simply didn't notice. So different forms of joins, and cross join is a new one. It's a new one for CRM Analytics. I believe that in SQL this already exists, and I've worked with it there. So right here you can see that it's joining the event record ID onto the event lookup in the event attendance instance. And what's really nice here is you can actually create your own keys. You can create your own unique keys if you don't have them. And very often that can be the case because there might not be a shared key between your external system and Salesforce. So in higher ed, in my previous life, the way that I did this is that students have a student ID and they have an email. And we would join them on either or, depending on what we found in our system. And it also depends on what your university does. If your university assigns a student ID at the beginning when they're just a prospect and not even an applicant, this will make things easier. If all you have is an email for them in the beginning and you don't update that email as the student progresses, then that'll make things harder. You might have to use other information about the student to create these joins. But you can join anything this way. So it's data from any source, including if you drop just flat files into CRM Analytics. So here you don't, the sources can be stored inside of the tool itself. And those files don't take away from your total Salesforce storage. They're stored inside of CRMA itself. Okay, so that is the join and that is the transform. Let me quickly show you a source. Like when you're engaging with a source, you have all the different fields available to you from that source. And you will be able to pick your columns here, but you'll also be able to pick your columns in connections. What is really nice is that they added a new feature where you can see that this broken link right here. And what this broken link means is that this field is available to me from this object, but I never included it in my sync. Before, if you got to this step and you simply couldn't see a field that you created, you'd had to guess that it's like, oh, I might have not included it in my sync. Now you can actually see which fields you didn't include. But if you do choose to include a field here that you need for your recipe, make sure to run the sync before you try to work it through the recipe so that you have the data available to you. And the sync is inside of the connections, and it can be scheduled on a regular basis, like to run at midnight, or to be triggered by another recipe. So let's say one recipe completes, triggers the next, then the next, then the next, so that you have things going in whatever order you want. And you can basically reinforce data quality this way. You can also do what's known as partial syncs, meaning that if you sync data from an object like a contact, you might have millions of contacts like I had to deal with. You're not going to sync the full sync every time because the amount of time that this takes would be too much. So what they have is they have incremental sync, which is sometimes called partial sync. They just take what changed from one object to another, and they pull that in. And you will also schedule at the same time full syncs for that object, because partial syncs can cause what's known as data drifting. There is a small chance that some things might get like deleted from contact that don't get deleted from your sync. Very small, because these changes are kept track of. But just to be sure, Salesforce does give you the option of, we're going to do a partial sync on Monday through Friday, but on Sunday, we're going to do a full sync no matter what, which is nice, so that your system can run quickly when it needs to and be accurate when people are not using it, so that when they come back, they have their exact data. This is all happening in here.
So it's better to do full sync, right? It's better to do full sync.
It is better to do full sync, but sometimes there'll be so many records. So let's say if I do full sync for a contact, it would be, let's say in my last place I worked, I had 3.5 million contacts. If I was to do full sync every time, it would take too long for the recipe to run. So what we have here is incremental sync. Let me show you. This is getting more technical than I planned on, but these are your options. So this is what I was describing, the periodic full sync. So sync records incrementally and periodically overwrites all records with records in Salesforce object. Use this mode to prevent data drift. This is probably my favorite one, the periodic full sync, because I can set it on the weekends to just sync everything that I have without worrying about data drift. And full sync will basically overwrite everything. I have this just default set incremental because this is how it was set when I created the connection. And I created 300 contacts, so I'm not as worried about data drift in this particular scenario. But let me try and speed this up because I don't know how much time I can take with our delay. So we have the recipe that we just created, the event yield recipe.
You have 15 minutes more.
50.
1-5.
1-5. Okay, and we'll try and go through this as fast as possible. So right here, we just completed a recipe, and we're going to go ahead and like output to this data set. We're going to save and run, and you let this whole thing run. It creates the transformations, it creates the new fields, it does all the calculations for you, then it deposits the data set. After it deposits the data set, you will then go back to your analytics app, and you will go to create. Up here, you will create a dashboard, and dashboard looks like this. So this is the event yield dashboard that I built for our presentation. And you can see that it used the data from the recipe to create a whole list of events. And for event names, I combined the fake city names with the date on which they occurred. And this is important because often you will, when dealing with events, you will run into an event that's been held year after year or month after month that's named the same thing, but happened on a different day. So this is how you differentiate between the events when it comes time to create aggregates. I created button filter here, which is just a toggle. And I've created, which is basically addressing the whole dashboard when I use it. And these drop-down filters, which will allow me to narrow down to only certain segments. Like I want attendees only for fall 2021 to basically see folks who were at that time attending. And then you just unclick it. And then for event filters, you have stuff like what I just talked about earlier with like what type of event it is, like a high school event, on-campus event, virtual event. These are things which matter a lot in higher ed. I imagine this is not what non-higher ed folks, which are this group is looking at. So event year, event country, things like this we look at, and you can see that this table right here that I created in the dashboard does not just list the numbers of like total confirmed attendees, total attended, but it also provides something called yield fields, like percentage fields. So I'm taking percentages of these different columns. So out of the total people who confirmed they were coming, how many actually attended, and that what percentage actually attended, and that is what gives you the attended yield, and how many applicants have out of all those who were confirmed, how many applicants did we create or did happen? So 12 people applied out of the 15 who were confirmed. So this is your applicant yield. And how many people whose applications did you accept? You accepted 73% of the applications that came out of this event. And how many of those applications that you accepted paid their deposit, meaning they actually enrolled? Right here, it is 67%. These numbers are very high. Typically, events in higher ed don't produce this many applicants. The percentages are usually in single digits, but they can be very widely between events. Then an event that produces 0% applicants versus one that produces 7% applicants or even 3% applicants will have a very different lifespan. You wouldn't want to continue an event that for like multiple years has produced 0 or very low numbers. And this is how you would see it. And basically you would go to the year. So let's say these are the events that were held in 2021. And you see what your numbers are for those events. And then you would go to the next year and you see like, oh, it appears that the same event, like this on-campus event that I'm holding, has yielded this amount in this year. So year to year, you get to see what the differences have been. And this is how you see how effective those events were. Of course, there are certain things that you can take away from this, but also be mindful of different, if you were to create something like this for your organization, I would be mindful of the year in which you are filtering, because of course, COVID year and the years following are going to be a bit different in how people have been interacting with your organization, whether it's higher ed or not. So take that with a grain of salt and try to extrapolate only from the years that are useful. So pre-COVID years won't necessarily equate to what is happening right now if events is what you're focusing on, because so much has changed with in-person events or going to conferences if you're trying to make sales that way, that making extrapolations would be kind of fraught with possible wrong interpretations. So I'm going to quickly go back to my presentation. I hope I have enough time. So next questions I wanted to answer, and I'm going to try to go through this as quickly as possible, is the data science questions. So what actionable things can I do to increase the quantity of applicants? What actionable things can I do to better move prospects through the admissions process? And what about prospect that makes it more or less likely that they will apply? You can think of this also as like the context, people that you're trying to sell to or people that you're trying to engage in your system. And the CRMA answer to this is to create an ITIN discovery predictive model. Valuable considerations when creating such a model are what fields do we want to check for correlation? What data do we actually have? Can we retrieve our marketing data? If marketing data is the type of data that you want to check, if it changed, for example, how many prospects are coming to you. So this is a way of measuring whether your marketing is actually pushing the needle, and if your interactions through marketing are correlated with a higher likelihood that prospect converts into an applicant or a sale is made. And lastly, what data can we legally use? I provide use cases later on for higher ed, but this was a consideration probably also in healthcare and sales, I think, as well, and definitely in insurance. So moving to the next one, what fields do we want to check for correlation? So this is an important point I wanted to make. When you're creating a predictive model, you don't actually know what will correlate, and it is better to accept that there might be interesting things out there and to allow for brainstorming to happen between the people involved in your existing process of, let's say, admissions or sales to say like, we want to look at all the different fields that we have, but also some interesting things like, let's look at how many SMS interactions this person had, or whether they opted into SMS or not, or what is their favorite ice cream flavor. You just don't know what will correlate. And this is a good way to look for things that are interesting and that nobody might have seen. And I've seen this happen for myself in person, where we brainstormed with a bunch of people the fields that we were going to take a look at, and the field that ended up at the very top of what correlated with the outcome we were looking for surprised every single person who was there, and it caused significant changes in the approach of the organization to what they were going to do for prospecting. So allow for more data rather than less. Now, when you allow for more data rather than less, you need to consider also, what data do we have? Do we have access to the data that we identified, meaning to the, let's say, Marketing Cloud database that you have all of your marketing information in? Is it controlled by your team or by a different team? Or how do you get access to the data after you've identified? You want to try and correlate whether your campaigns actually and their engagement leads to a higher probability of a sale or a prospect becoming an applicant. And then you say, is the data that you identified available? Are there gaps? Meaning that, let's say you identified a certain field, but that field has been filled in for only half of the prospects that you're looking at. So that's a 50% gap in all the prospects for whom this data is available, which is going to create something called data skew. And you might want to omit that, or you might want to change your model to simply say, for all the people for whom this field is available, show me what correlates. It might be a really important field for which parts are missing, and this is how you might want to filter down, because the answer might be that important to you. And the last part is, the data clean or will it need cleaning? This is self-understood. Fields constantly change names, new pick list values appear, disappear. Things get renamed, whole fields get renamed, field types get changed. And for admins here, I'm sure you remember all the different field types that if you change them will erase the data that's in them, and what field type changes will retain the data, and what field type changes will erase the data when you change it. I hope that you remember those, because that's in your admin exam if you haven't already taken it.
That's right.
So this is a big thing that you'll run into when you say, like, is the data clean or will it need cleaning? Is the data available or is it not? And these things will actually initiate really interesting conversations that I'll talk about later, about how we retain data and what data we're going to retain in the future, and the importance of doing so. This could cause a whole cascade of, like, we're going to keep backups. It's a whole bunch of interesting things, because the predictive models you create here could be that valuable. Next question is, can we retrieve our marketing data, which is what I brought up earlier. In higher ed, we use systems such as Pardot and Marketing Cloud, which are used more broadly by everyone else, and TargetX, which is kind of higher ed specific, and many others. And is the relevant marketing data retrievable? So for example, if you try to retrieve it from Marketing Cloud, you'll realize that the data architecture of Marketing Cloud is tough to discover, and it'll only give you the interactions between you and your prospects for the past 3 months in a query. So you will have to find a way to retrieve historical marketing data, combine it with current marketing data, then attach it to your predictive model. So it's a multi-step process. And to anticipate that it will not be easy, basically, like if you imagine any system, just like first look at what it takes to do it, then try it, then get back to either your coworkers or your client and tell them, this is how difficult it'll be. Do not assume that it will be easy to get it out, because I made that error and it caused a delay in my project deliverable that I'm hoping to save you guys. And the next question is, what data can we legally use, which is higher ed focused. So in higher ed, when creating things that differentiate based on gender or ethnicity, there's several considerations. Gender is not allowed to be used as a consideration in admissions for public colleges, but is very often used in for private colleges to differentiate between how you're going to treat the different applicants. Ethnicity is not allowed to be used as a consideration in certain states, such as California. And there may be others. I just happen to know that one up from the top of my head. And surprise. There's always surprises when you go through this exercise. So I'm giving you a list of a couple of higher ed specific surprises. So in higher ed, we can elect ethnicity often only for domestic students because it is required by the federal government for aid and other purposes. We do most of the time, they do not collect ethnicity for international students. So if you decide to use ethnicity in your predictive model and you're legally allowed to do so, bear in mind that you will need to exclude the students for whom you did not collect this. Things like college of choice. As you can imagine, a freshman starting at a college does not pick which college they're going to, but only a transfer student does. So if you decide to prescribe something like college of choice and look for a correlation between, oh, do people who apply to certain colleges, are they more likely to actually complete their application? That's not going to be that useful because only transfer students will have that field. So that's like a gotcha you got to watch out for that I'm sure is available in many different flavors outside of higher ed. Different things that you collect about your prospects or contacts or sales folks can also be not collected evenly. So for example, in higher ed, as many at least US-based folks know, the two major scores that are collected when you apply to a university are SAT scores and ACT scores, but not every person is going to have both or even one or even any, meaning that one person might have just SAT, another one SAT and ACT, and another one neither, because they can completely opt out nowadays at many universities from even submitting these scores. It is now allowed. And that might be a flag for you to also consider. This is one of those surprise flags, like if a person opts out completely out of submitting scores, does this somehow correlate with the outcome in their future? And certain information such as scholarships. So we talked earlier about how pick list values can change. In higher ed, we have scholarships that appear and disappear on a regular basis that we can apply to students because funding for certain ones runs out, or new ones are created, or an old scholarship is renamed. And you have to watch out for those when you clean data. And I'm sure you can extrapolate these challenges to outside of higher ed as well. Just look at what fields organically appear and disappear. And if you're doing predictive modeling on those, be sure to explain this, that the historical data you've collected in this model will not all have the scholarship information, and you should not measure the scholarship against others because it was simply not even selectable or doable in the previous years. And you will always have new surprises. This is a short list. And I will quickly demo the Einstein discovery piece. This will be a shorter demo than the other one. I think I might already be like pretty short on time. So here, I have already created the connections and the recipe for the Einstein discovery that we're going to need for all the higher ed objects that we talked about. I combined, in our case, applications with prospects so that we can see what about a person or their application is correlated with the outcome of that person becoming an applicant. And I put in a bunch of different fields. So the recipe that I created, well, it pumps out a data set called application prediction model. This is just the name of the data set. This is not the model itself. And oh, hold on. This is what's called a lens. We're not going to go into what lenses are at this moment. I'm going to go to data manager and go strictly to my data assets and go straight to the data set right here. And from this data set, we click this button right here, which is called create story, which is what will trigger your, let me just show you. I'm trying to actually do at the same time as speak and not keep doing it the other way around. So you want to analyze your data, your prospects and applications for whether somebody is an applicant or not. And you have created a field in your data that differentiates between applicants and non-applicants. And I have created such a field called is applicant in exactly the way that I showed you earlier. And here you can choose to maximize is an applicant equals true when you search for these correlations. You can also use numeric fields here. So this is where you would see like, if you want to maximize how much people have paid for or are willing to pay, or see how much people are willing to pay based on other people who are like the person who you're currently looking at, on all the different things that correlate with their likelihood of what things to offer to sell them in order for them to most likely buy them. This is where you would do it. So you can maximize numbers, or you can maximize a binary true or false field. So you will then go to create next. Here you will select insights or insights and predictions. We're going to stick to insights only. I'm not going to go into predictions right now because we don't have time. And here I would recommend manual controls. So once you go to the next field, you will have potential to pick all of the fields that are included in your data set. And as you can see, I've included many fields here. Now I'm going to close out of here and go to, and if I was to go ahead and click create story here, it could take some time to run. So instead, I'm going to go ahead and go into the story that I have already created for this demo. So once you click create on the story, it will run the story, and then it will pump out something that looks like this. And what this is a list of correlations and what things are most correlated. So it looks like what's most, and this is completely fake, by the way, like all this data I learned how to create in massive quantities, but everything is fake. So do not think that this will apply to any university at all. You have these correlations up here, which are actually in low numbers, and they're not always in low numbers, but these are low simply because of the random nature. So I picked the fields to include here: SMS interactions, email clicks. So I included marketing data, lead sources, and favorite ice cream flavor apparently make a difference in the likelihood of somebody applying. High school GPAs, ACT scores, whether somebody opted out, what scholarship somebody got, their college of choice, citizenship type, email opens, and SAT comp scores don't make a difference. Now, the reason I listed those out is because of how valuable the zeros are. So what the zeros tell you is that this, like for example, high school GPA is not at all correlated with the likelihood that somebody is going to apply to your university. Of course, this is not true, but this is all fake data. The important part here is that here you will learn about assumptions you might have historically been making for years about how important a certain variable is in the likelihood that somebody will apply, and this will change everything on the dime. Right here we see that SMS interactions seems to be the highest correlated field, item, artifact with the likelihood that somebody will become an applicant. And you see the numbers, so it's using numbers. So people who interact between 33 and 36 times have a likelihood of applying of 88.46% is what it's telling you here. And the likelihood of somebody who interacts only 11 to 17 times is only 48.48%.
So can I interrupt and ask you a quick question? So do you find that you get challenged? So you do this and the people are shocked to find out which stuff is important, which ones are not. But do they challenge you and they want to see your data? And
yes,
Okay,
and it is
that's what I thought.
beautiful because it's a learning opportunity for every single person there. We learn about if our data is good enough on our end, and if we have all the data that we need, because challenges are fantastic. There's only so much that you can keep in mind about data as a person from, let's say, the technical team, that the people from the business side know that you do not know. Like, let's say that I'm going to go here to lead source. And lead sources for applicants can come from events, self-inquiries, LinkedIn, and a whole bunch of others, like nonprofits, Facebook, I put everything in here. I put a whole bunch of examples and purchase lists. So you go to College Board and you purchase a list. And let's say for all these years, you've been purchasing a certain list that is apparently yielding you nothing. There's no correlation with somebody coming from this list and the likelihood that they will apply. As a matter of fact, it might actually be inverted. So you will see in here both positive correlations and negative ones. So I did not design this to show this so clearly right now, but when I created this before, you can change colors here and you can add more sources, like more columns, and you can display this more clearly. But essentially what it tells you is that you should not buy this anymore. And this might have been like a go-to list for people, or that a certain nonprofit who is sending you prospects hasn't really sent you quality prospects, and none of them are applying, even though you might be reaching out to them, and it might not be worth the time investment that you've put in with constantly receiving data from them in some kind of intense system that delays your other processes because you're waiting on their data to come through. It creates so many different decisions. When you find out what is actually correlated, your entire marketing strategy can change, which is what I saw. Your website design will change. The things that you will put forward in front of students will be different than what you did before when you realize what is actually a higher predictor. Now, this is also where I say the huge caveat here. Correlation is not causation, meaning that if somebody was already, if SMS interactions are high, and that's a correlation between whether somebody's likely to apply, it could either be caused by the fact that you have reached out to them and have messaged them many times, and maybe the person who they're speaking to on SMS is actually like a really good recruit. It could be that, or it could be that somebody who already intended to apply simply naturally has a higher tendency to message more. So this is the business side where you will ask these kind of questions. It's like, oh, you know that what your data is telling you, but the business case might be completely different. And this should not be used as a correlation. However, if it is used as a correlation and people realize, oh, wow, this is working better than our like Facebook marketing, we need to switch to getting as many people engaged with our SMS as possible. All of a sudden, SMS opt-ins appear on all the different forms that you have. And on your website, it's one of the first things that you ask because it's such a useful predictor. Another more interesting example of correlation and causation difference would be if you're advising students, and I've seen this in person, done with a live data set where Salesforce, who was demonstrating this, tried to show people correlations about how many times a student visits their advisor versus their likelihood to graduate. And what they were doing is in the model, they were changing the field that said how many times the person went to the advisor. And when they lowered it, they actually anticipated for the likelihood of that person to graduate to decrease. But what happened is when they lowered the amount of times that the student went to an advisor, the prediction model told them that the likelihood of that person graduating actually increases. So what that actually meant was that people who are already doing good do not go to see their academic advisors. And that's why they are more likely to graduate. It should not be assumed that by lowering the amount of times that a person goes to the academic advisor, you're going to increase the rate of their graduation. So this is the catch that could happen and why you need so much input from the business side when you do this, and the fun questions that will come out of this. And you will have surprises, they will have surprises. This will be, these two things that I just demonstrated have been the highest return on investment for the folks who I worked with. The events dashboard and this Einstein predictive model. And the amount of changes that have come out of both have definitely pushed the needle. And that is all I had. Is there any questions?
Karen, you can stop recording.
No questions, but that was really, really awesome. I followed that. That was great.
That was great. Thank you.